testing. We decided in here that unit testing is a good idea. So you have a test driver, the JUnit, and you have class under test, and you apply some stimulus to the class under test. You call some methods, right, on it, and then you assert that something expected happened. Piece of cake? Easy? So why are we having this discussion? Why is this so hard? What's the problem with this model right here? Yes? Things often have dependencies. Exactly. So the reality of it is that the class under test usually has these other classes it depends on. And guess what? Those things depend on other classes. So I do something benign, like I say new class X. And in the constructor of it, it goes off and starts constructing other classes. And those classes in their constructors go off and construct other classes. And so on and on and on and on. So we have the same problem as we had with procedural programming, as you pointed out at the beginning. If it's a leaf class, yeah, it's a piece of cake to test. Nobody really has to explain to me how exactly I test array.sort. Yeah, piece of cake. It's a leaf. But how do I test, oh, I don't know, the login page? Totally different end of the things. So in order to test this thing, really need something we call the seam. We basically need to be able to take a knife and then kind of cut all the dependencies. And the seam is important because it allows us to divert the execution of the code. This is why procedural programming is problematic, or rather static methods are problematic, right? Because if you call another static method, there's nothing I can do in a test to prevent that call from happening. Now, I'm sure you can come up with a simple case like, oh, but I'm just calling math.absolute value, therefore it's OK. But usually, when you have some static utility method, people keep adding stuff to it. And so what started off as a benign method call, which was non-interceptable, ends up to be this complicated beast that all of a sudden is non-interceptable, and all of a sudden it's not so good. So I take the extreme point of view, and I simply say, in my code, I don't want to have any kind of statics whatsoever. It turns out that in most cases, when I see static calls, I usually look at them and I say, yeah, this actually belongs on this class over here. And there's something wrong about the OO decomposition of the project. For example, let's take the extreme example of math.absolute value. I firmly believe that the 5 should be able to say 5.absolute value. Why do I have to say absolute value and pass in the 5? It should be just a compiler sugar that does all the magic underneath it. And I believe in languages like Ruby, you can do that. That doesn't imply that the 5 has to be an object. It just means that the compiler knows how to convert all these things. So we need to have a seam. So great. So we have a seam. And what seam allows us to do is to replace these dependencies with friendlies. Now, when I say a friendly, I don't necessarily mean a mock. It could be the real class that I'm already tested somewhere else, and I already know that it's going to do the right thing. Therefore, I'm perfectly happy to instantiate the real thing. But I trust it. I know when the test fails, the problem isn't over there because I have other tests to prove that that stuff works. It could be the real thing. It could be a stub, such as that it does nothing. Like, for example, in a logging framework, I'll just throw in a stub so that you don't bother logging anything because it's not relevant for the purpose of the test. It could be a mock which returns some collaboration. It could be a simulator kind of a thing that kind of simulates the thing, which is kind of like a smarter mock. The point here is not what you put over there. The point here that from a testing point of view, I have a choice to place anything I want over there. And that requires a special way of writing code. If you in your code just simply call the new operator on a class, well, there's nothing I can do, right? Even if you create an interface for these things, but if you instantiate the implementation of the interface, there is nothing I can do from a testing point of view.
This is not going to be an introductory talk. I'm not going to give you a lot of details about the syntax of JUnit or how you write your setup methods or your fixtures or anything like that. What I want to talk about today is, given that we're writing tests in whatever language, Java, C#, C++, Python, doesn't really matter, given that you're doing test-driven development, given that you're writing unit tests, how do we do this more effectively? How do we get the most bang for the buck? How do we improve our development process through testing? So why do we write our tests? Well, I know why I write them. Number one, because I want my code to work. If it isn't tested, it's broken. I actually found that out this morning. I was looking at some code in Cloud Tools for Eclipse, and one of our developers had proposed refactoring. I said, well, do we have tests for that class? Oops, looks like we forgot to test that class. So I started writing some tests for that class, and wouldn't you know it, I found a bug we didn't know about. And now I've got a pull request out for that. Still needs a little work. We also write tests because we want the code to keep working. Very many times when I make a change, when I send out a pull request, a test I wasn't even thinking of fails. So that keeps me from committing it. It keeps me from breaking the things that already work. It's also important to write tests because I want to write code faster and with fewer regressions and more confidence. You know, sometimes people say, we don't have time to write tests. We have to just, that's great, we'll do that later. My answer is, I write code a lot faster and I get to production a lot sooner when I'm writing tests at the beginning. It actually lets me move through, it lets me see the mistakes immediately rather than seeing the mistakes down the line where they're much harder to fix. It also lets me understand my code better in terms of what I'm doing. It lets me think about the code. It speeds up my development. It sounds counterintuitive. You're writing twice as much code, but you can do it in half the time if half of the code is tests. And of course, we write tests because we all make mistakes all the time. None of us write perfect code. I am constantly amazed how many times I write a test for a method that's too simple to fail, and wouldn't you know it, the test fails. And there's something I didn't understand about that method, and it's not nearly as simple as I really thought it was. Even basic methods like set foo string s, this dot s equals foo, those can fail. Now, I'm going to begin with what I think of as the fundamental principle of unit testing in any language, in any framework. This is something, though, that is often sort of missed. What is a unit test? At its base, it's this. It's a piece of code that verifies that a known fixed input produces a known fixed output. Known and fixed are very important. You want to avoid any cases where you're trying to parameterize your tests too much, where you're sending in random data, where you're sending in time. If you have a method, for instance, that tests the square root function, test the square root of 9. You know what the square root of 9 is. It's 3. Don't test the square root of 17. You don't know what that is. Don't test the square root of 2. Maybe a few people know that to about 4 decimal places. Anybody know it beyond 4 decimal places? But you're still worrying about round-off error and things like that. Try and aim for, the test says, here's the input, and you want to test where you know the output, where nobody's going to argue with you about what the output is. Fixed output. Anything that's going to make the input or output contingent or dependent, you want to avoid. You should never, for instance, generate random input. You may want to do fuzz testing, but that's a very different thing. And even if you do fuzz testing, you need to carefully record what values you fuzzed with, or you can't actually fix problems you discover. So always use fixed values for unit tests. Very controversial point, I prefer not to use named constants that come from the model code. If the model code has a named constant like webinf folder location, I won't use that static final field in my test. I'll just use the string literal. This gives me an ability to test if the named constant is actually incorrect or if it changes. I don't want changes in my model code to automatically change the tests. I want to know when the tests change. I want to know that the changes are deliberate. Other things that can be problematic because they make your input not known. That would include any sort of network access. This is a mistake I've made in the past myself. And preferably not the file system. You can probably get away with the file system if you need to, but it's a little flakier than in-memory access. And then the final thing I'll note is if you depend on something in the environment, the time of day, the speed of light, the gravitational constant of the universe, I don't care. The geographical location where the test is running, that most often sneaks into our tests in an unexpected way through time zones or default character encodings. Don't let that control the output of your test. If necessary, inject these values, inject a clock into your test, inject the gravitational constant of the universe, whatever it may be, so that you're not dependent on these things that are outside of your control in the environment. That's unit, of course, means one. Each test tests exactly one thing. What a test is depends a little bit on your framework. If you're in JUnit, basically each test method, each method with a test annotation or begins test, that is a single test. Not a test class, but the method. In other frameworks, it can be a little different in terms of what constitutes a single test. But every test method is one test. Best practice that is often observed more in the breach, one assert per test method. Each test method makes exactly one assertion. And if you want to set up your list and then assert 10 different things about that list, the way JUnit at least expects you to do that is you have 10 different test methods and they can share the same setup code to set up the list. And that makes debugging a little easier. It lets you see what's actually broken and see how much is broken when you run your tests, as opposed to a sequence of 10 tests where as soon as the first one fails, you get no information from the following tests. So one assert per test method. Share the setup in your setup method or your fixture, whatever that looks like in your language of choice. Something that is often forgotten is you do not need to have an exact one-to-one ratio of test classes to model classes. It is perfectly okay that if you have one model class, dialog frame buffer or something, that single model class can have 10 different classes that test different components of it. Generally, they will set up the class differently. So that, I would say, in a lot of code bases, we see not enough test classes. We see too much crammed into a single test class, and that means that you've got a lot of setup code in each class that only applies to half your test in the class, a quarter of the test in the class, one test in the class. Even more important, though, unit test means independent. The individual test methods can run in any order. The input to one test does not depend on the output of the previous test. And test runners in practice do reorder tests. There's no guarantee what order your tests are going to run in. Generally, if you're running in Eclipse, if you're running in Travis or Jenkins or something like that, and you don't change your JVM and you don't change anything else, it's probably going to be the same order from run to run, but then you pass the code to your fellow developer on your team, and they're going to run it in a different order. And then you upgrade your JVM from 1.7.0.49 to 1.7.0.51 or something like that, and your tests start running in a different order. So if there's any order dependence, it can bite you, but at unexpected times. So watch out for that. Tests in some test runners run in parallel in multiple threads. There's no guarantee that they are running in a single thread. So tests should not. Okay, speed of tests. How fast do you want your tests to be? Your entire test suite for your product. As fast as possible. Sometimes that's not fast enough. I mean, we're having that experience with Cloud Tools for Eclipse where it takes on the order of 10 to 20 minutes to run the entire test suite. I would say that's too slow. We'll talk about what you can do about that. But any given test, any given single test or test class, a second or less, so you can run it very quickly in your IDE when you're developing, get a very fast feedback cycle going of tests, see the failure, fix the bug, run the test again, oops, it still fails, you didn't fix the bug, fix it again until it passes. So the individual tests ought to run in a second or less, 10 seconds maybe if you have to. A complete test suite, probably a minute or less. If it's going to take longer than that, start separating your tests out into multiple suites. Start by running the faster tests first. So if you have early failures or if you've just done something that breaks everything, you'll find out immediately. You don't want the incredibly long-running database integration test that takes 15 minutes just to set up the database to start before you've got your test for the set foo method if they're both broken. Might as well find the bug sooner rather than later. And the faster your tests run, the more frequently developers will run them in the developer's workstation. Another anti-pattern to watch out for: conditional logic in tests. If you see for loops that iterate across every element of a collection are fine. But if statements, if x is greater than 5, we're going to assert this, else we're going to assert something else, that should be two separate test methods, not one, with different input values and different setup. When you see something like this happening, the risk becomes one or both of these are not actually executing. You may not be testing what you think you're testing. You may not be getting the coverage you need. It is very easy for these tests to not actually run when conditional logic sneaks in. Try and make, again, remember that known fixed input, known fixed output, and no choices in the middle. Okay, development practices with tests. Debugging. This is easy. If you find a bug in your code, it's shipped, it comes in from a user report, or a tester reports a bug, or you just happen to notice something, stop, think, don't fix the bug. File the issue, write a failing test. Make sure that test is read. Make sure, and once you think you understand the bug, you can write a test that addresses it, you run the test, and as often as not, the test passes and it's green, which means you didn't really understand the bug in the first place, or the bug isn't where you thought it was, or maybe the test doesn't really expose the bug. So whatever of those are true, you iterate on the test until you finally get a failing test that says, aha, now I understand the bug, and then you can start fixing it. And then, when the test goes green, I can stop now. I fixed this bug. Furthermore, since the test becomes part of your test suite, you're running for the rest of time, the bug should not reoccur, it should not regress. Or if it does, it will be caught immediately before it ever gets checked into the repo. So for debugging, always get that failing test first. Nothing drives me nuts more than when, a bug gets assigned to a developer and then I get the code review and, here's the fix for the bug and there's no test change anywhere to be seen. Because even if I go ahead and then ask them, okay, could you please write a test for this bug? How do I know that the test really actually addresses the bug? Maybe it's just some sort of random
crowd. That was a joke. Now, the first mistake is that people believe that just by doing it, unit testing will make your life easier. You hear it in everyone who talks about unit testing. Unit testing is amazing. Unit testing will make it easier to find bugs. So imagine that. When you have 4,000 unit tests in your code, it's easier to find bugs. Well, that's absolutely wrong. Most of the time, what happens when I come to projects and do consulting is that the tests themselves have bugs. The tests pass when they shouldn't be passing. They fail when they shouldn't be failing. And so there is no trust in the tests. So how do you make sure that your tests don't have bugs? Do you write a test for your test? How does the test for your test, how do you know that doesn't have bugs? So writing a test for the test for a test doesn't work, I can tell you that. Now, one way to solve it would be test-driven development, in which we see the test fail and then we see it pass without touching the test. So we're actually testing the test this way. But most projects, it's actually not easier to find bugs unless you pay close attention to what the hell is going on in the code and the tests. And we'll see how to fix that. Another thing that everyone says is that it's easier to maintain your code when you have something like 1,000 unit tests, 4,000 unit tests. And again, that's absolutely not true. Because the tests, if they test a lot of internal implementation, what you end up with is that you refactor your code, and then suddenly you have tests breaking, even though they should actually be passing, if the code still works. And so you have to go and start changing the tests. And at some point you start saying, you know what, this isn't worth my time. And then you start removing tests, or actually commenting them out, or putting ignore attributes on them. So that's not necessarily true. And I would say that most projects that fail with unit tests, it's because of the maintainability issues. One of the first projects that I've had, we had to delete some of our tests after just a few months of code. It's easier to understand your code when you have 1,000 or 4,000 tests. Well, I know that that's not true. For most of the tests that you've seen, most people, especially when they start out with tests, what they see and what they think is that the test code is not as important. So they just give out names like, just test one, or test add, or test whatever. And then the test code itself is just, just assert on the thing and be done with it. And then the tests end up just like you treated them, which is they don't help in terms of readability. So we'll talk about readability issues today as well. But only when these three things are true, it's actually easier to develop your software when you have unit tests. And most of the reasons to do with why companies do not adopt unit testing into their organization is because they're failing with one of those, at least. And then that affects the other two. And that creates a very big chain reaction. The second big mistake is that once you've started doing unit tests, you do not do any test reviews or code reviews. So some companies do actually do code reviews, but most developers that I know do not do test reviews. So they review the code, but only some of it, and only at specific times. But the point of a code review and a test review is that you teach and you learn about practices. So you might have one person who really knows how to write good unit tests in the team, and that person is just writing there. He's just sitting there coding awesome tests. But then everyone else around him is just create a pile of manure around. So when you come and see the test, you see a good test, and then right below it, a test that has no business being there. And there is very little communication about the quality of the tests. So test review is one of the best ways to actually institute code reviews. Because if you think about it, tests are really mini use cases of your code that you can drill into. And you can actually understand very, very quickly whether the developer actually understood the requirement or not. Sometimes just by looking at the name of the test, you can actually understand that the developer did not understand the requirement. You don't even have to drill into the code. You don't have to read 50 lines to say, oh, no, you're doing it all wrong. Sometimes if the name is good enough, then you've saved all that time. And when you do code reviews and test reviews, it has to be in person. You cannot use a tool. If you use GitHub to do reviews of the code and all you do is in comments, yes, that's good, but it's nowhere nearly as powerful as pair programming with that person, or actually even doing remote desktop or anything like that, where that person can see the expression of your face, where you can hear the tone of their voice. A lot of information is lost. If you ask the person something and they hesitate, that's something that doesn't go through in comments. If they keep fixing their answer while saying it, that doesn't go through when they write text. You only see the end result. So you can tell where there's things that they're weak, their knowledge is weak on, and you can help them learn something. Or even better, you learn something from them. Why did you do that? That's something that maybe you wouldn't have written in a comment on GitHub because it was just a little thing. And it has nothing to do with the current code review. But you just saw that and you would have liked to say, hey, what was that little thing you just did? Or that you wrote there. But that's not about what you're doing, and then you don't write it in the comments. And maybe it's too large to start writing the text about it in the comments. And so a whole opportunity for learning something new is lost, a new technique. If your team is learning and not doing code reviews and test reviews, I would highly suggest that you start doing it. If you decide to do it on all the code. Okay, one big mistake is that people use mock objects and stubs for everything, when instead, they should actually be using them very, very little. So I would go far as say that maybe 5% of your code on your test should have a mock object. And when I say mock object, I don't mean a stub. And the difference between a mock object and a stub is that a mock object is something that you will verify against at the end of the test. And a stub is just something that makes happy noises. You might have multiple stubs in a test, but you could have usually only a single mock object because it tests a single end result. Let me be a little more clear about that. When we're talking about unit tests, when I say the word unit in a unit test, what I mean is a unit of work. I don't mean a method. I don't mean a class or anything like that. What I mean is that there could be multiple methods or even multiple classes running in memory, and they get invoked by some public API somewhere. But then the test invokes a public API, and then many things happen in memory. They do not touch the file system or a database or anything like that. And then at the end, there is either one of three possible end results. You might get back a value, right? Methods that return something. You might have a void method, and then the void method has to do something as well, right? Void methods don't return values, but why would you call them? They must be doing something, and that is usually to change the state of the system, a noticeable state change in the system. And the third type of end result is when they don't change the state and they don't return a value. Why would you have such methods? When you forward calls to a third party, like some kind of logger or web API. And only in that third type of end result do mock objects actually make any sense. That's the only time where you have a fire and forget into an external framework. When you try to test on a third party without a mock object, there is very little way to check that you called Twitter the right way, etc. So if you try to assert against it, it will be really, really difficult. So instead, what we'll do is we'll have a mock object that looks like the Twitter, either not Twitter API, but a facade that abstracts it away. And if that was called, everything is good. That's the only time where mock objects actually make sense. But since the beginning of mock objects in unit testing, people have been abusing and using them much more just because they could. And that has then created a lot of tests that are very brittle, very hard to maintain, that would break on every little change to every internal implementation in the code. So 5% is maybe the amount of calls that you have to external APIs in your code. That's how many mock objects you should have. But remember, this is only a fire and forget scenario. If you fire something and you get something back, that doesn't always mean it's a mock object. It could still be a stub. It depends on the flow of information. So only if the absolute end result is calling a third party, it makes sense to use a mock object. Now, another very, very common mistake that I see is that people say mock this, mock that. Everything is the word mock for everyone. But there should be a differentiation. Now, if you read the book XUnit Test Patterns, you've seen all these things: test spy, test double, fake, mock, stub. And all these things mean something for all these somethings that look like other somethings. And that's a very, very complicated thing, especially for someone who's relatively new to this field, to understand. And what I find is that if I use a simpler terminology, and I don't use all these, I just have three things that I talk about. I have fakes. Fake is everything that looks like something else. And then if I assert against it, then it's a mock. If I don't assert against it, it's a stub. And that's the only differentiation. If you take this coarse-grained differentiation, you can start talking about the difference between mocks and stubs and not call everything a mock. Instead of saying, I'm going to mock this, I'm going to mock that, usually what you mean is, I'm going to stub this, I'm going to stub that. The only time you should say, I'm going to mock this, is when you are expecting this to be called. But even frameworks use the word mock too much. And mock is very, very overloaded. And again, the differentiation is you only want one mock per test, because you're testing one thing. You could have multiple stubs, so you need to know the difference. Third, state-based. One of the nice things that happens is that if you don't use mock objects, you're getting into very simple test territory. Sometimes it's just invoking a method and then checking that some state has changed. But you can even get that a bit into some problems. For example, you might be checking that an internal state has been changed. So imagine that white line being the boundary of your API. And the test that invokes the public API should only be asserting on an API at the same level, no level deeper. Because if you do, you're bound to get weird things. For example, look at this test. It adds a user in memory, creates a user, and then checks that there is an internal field somewhere that has the user in memory. Now, this test will pass, but it doesn't mean that the code works. Because you're checking internal implementation, what's going to end up is that maybe the other methods that have to use that user are using it wrong, or they're using a different field. So even though private implementation works, it doesn't mean that the unit of work actually works from the same level of the public API. This is a better implementation of the same test. If you could do that, create a user manager, add a user, and then check that you can log in with the new user. So noticeable state difference in this case is that the behavior of the object or the system under test is different than it was before you changed the state. Either a method returns a different value, or a different method returns a different value, but it's still at the same level of the API. It's not checking internal implementations. It has the same problem. When you get the latest version of jQuery and you run all the tests by default, you get this. Well, actually, you get this, but if you run it again, it takes 7 minutes, by the way. If you run it again, you get this. Okay, so it was 137, now it's 136 failed. What the hell does that mean? What am I supposed to think? Does it mean that jQuery has bugs? Probably not. What it does mean is that if you start digging around and start to look at all the tests that are failing, you're going to start seeing things like this. Oh, you require PHP and a server running locally to be able to run the AJAX-related tests. Makes sense. But then these are not unit tests. But all those tests that require PHP are in the unit folder of the tests. And there is no way to easily run just the unit tests of jQuery. So I had to start looking around, and of course, I thought, does that make sense that you have to have PHP running? And of course, Google will tell you, yes, you need PHP installed, etc., to get jQuery working. Not just installed, you need a server running with PHP and those files being served up. And again, you have the trust problem. If I wanted to do development, this is an open source project, so I'm comfortable with the fact that I have to set everything up and make sure that everything is working before I do the first thing. But if this was a team, if this was a project in a team, in a company, I would not expect that there to be that kind of separation, of non-separation. I would expect to at least have a safe green zone that says, these are all the unit tests that should be passing no matter what, no matter what. If we want to trust our tests, we have to remove logic from our tests. So this is an example of logic. Again, these are tests from jQuery. This is a test that actually generates a very, very long string, and it has a loop. And obviously, that seems very, very innocent. But the point is that this is a broken window. Someone else looks at this and say, OK, it's OK to write loops. Right? And then later, what's the point of logic is that if your tests have bugs, it's very hard to find. Any piece of logic in your test is destined at some point to possibly to have a bug in it. So I want to avoid that. Unit tests should just be very, very clear, simple statements. I can save all the loops and the random numbers and all that stuff, and I put them in a special folder called integration tests. Those are all the things that either require logic or anything else. By the way, there's something else interesting here, is that if you look at the top of the test here, there's a number, and that's the number of a bug that they fixed because there was a problem. And when I have those bug fixes, especially when it's hard to recreate or they require special attention, what I like to do is that I separate those tests that recreate bugs to another special folder called bug fixing, or something like that. And in that special folder, you can have all these crazy animals, because obviously that's the only way, or that's one of the only ways you can recreate this bug. You have to have a really long string. You might read it from a file, you might generate it, you might have it in memory. You still need that long string, and it's still going to either hurt readability or the maintainability or the trust of the tests. So I put them in a special folder, and then all those tests, you're allowed, in a way, to have these broken windows, because that's a different building with different windows. But the safe green zone and the lightweight test should not have any broken windows. Here's another example from a different test. This is checking about the percentages of working with CSS in different browsers. They even put a comment. Have to verify this as the result depends upon the support that the browser has for font size percentages. If you have to put a comment in, first of all, it probably should be a different test with a good name. But second, that if could also have a bug, right? It looks really, really innocent, but even the innocent stuff, I'm sure, if you've had more than 3 days experience as a developer, you know that even 3 lines of code that look very innocent might have a very uninnocent bug. One of the things that I saw in a lot of frameworks, in the open source frameworks tests, is that there is a lot of forced assertion counts. So a lot of the frameworks, especially QUnit in this case, they support the idea that you can say how many asserts you're going to have in the following test. And then if some of the asserts don't execute, your test will break and say, no, no, you told me there would be 5 asserts, but there were more or less. And that's, to me, I don't think that's a big problem, but it's definitely kind of a maintainability issue, because I don't, it's not that big a deal, but when I asked John Ressig, why is that? He said it's a bit of extra work, but it's good to know if the suite ever stops running for some weird reason. I think that's not a bad reason to have it, especially if, again, you're managing an open source project and you do not know all the people who contribute to your code, and you don't really trust that they will remember to write tests in a way that don't break and maybe in async way will not run or something. So maybe in that way, it makes some kind of sense to implement this. But then you look at tests that have 78 asserts expected. So saying, okay, this is getting a bit out of hand, because can you imagine adding another assert to that test and then having to go to the beginning and then add and replacing it to 79? That's like working at a very, very high bureaucracy company. No, this is the number of expected asserts. And of course, you know that when people started running this, they just counted how many asserts they think they had, and when the expect said, no, no, you have a different number, they just changed it to that number at the beginning, and they just kept adding 1 and 2 and 3. And then you have 119. That's interesting. This is just the beginning of the test, of course. And you start seeing, now we're seeing a different pattern. The reason we have 119 asserts in this test is because this isn't really a test. This is a test suite, disguised as a test method. And in that test method, we're testing all of the possibilities relating to jQuery.when. And then what happens is the developers are then encouraged, because they see the other tests, to then put new tests at the bottom of this method. And then they change the expect. So it's really a test suite disguised. And then each assert is really a different test. And then, of course, you cannot really give it a good name. You just have to give really good error messages. We'll talk about the error messages in a second. And then you have this, right? This poor guy. He just wanted to write a simple test. Still has to say expect 1. Now, in terms of readability, one of the things that are hard to read, when I was looking at the jQuery tests, I was looking at this test and I said, well, you're expecting the word blog from this thing to appear in this SAP thing, etc. But where does that actually exist? And then I had to start thinking, where is that coming from? And nowhere does it mention where the text is. And of course, once you realize it, you understand that the test runner, the index.html test runner, actually contains all the test data. And there's a shared, it's basically a shared resource. There's an HTML page where all the tests are running on. And then you have to go and you look at this page, and you see, oh, there it is. Okay. But then you realize that all the developers who write tests for this, each one of them probably adds a line to this page, hopefully. If they don't, what they would do is that they would manipulate this in memory as well. So imagine that you have 6,000 tests all manipulating the same piece of HTML, and they all have to coincide with each other. They all have to make sure that the other tests have the same state, etc. And that's kind of also could be a maintainability problem. Here's another example. Somewhere up there in the beginning of a very long test suite, there is a declaration of a variable, and then somewhere down below, there is the usage of that variable. Very, very annoying to try to read and understand that test. And then what happens is that, again, developers look at the original broken windows and say, okay, all the variables are defined at the top, because this did start out as a test method. But then more and more things were added. So someone at some point said, oh, you know what? It's 100 lines of code, but all the vars are in one place. I'm not going to do a different thing, obviously, right? So I'm going to put the var in the same place. And human psychology is the same way, right? You know the experiment. You put everyone in an elevator, all the people, they are actors, and you get one person into the elevator, and everyone turns around to face not the door. And then the person who's the innocent looks at everyone, and he turns the other way as well. Why? He doesn't know. He does what everyone else does. And that's kind of the point, is that here, instead of aiming for the pit of success, we're giving people a template of how to make the tests more and more, or less and less maintainable. Comments. I'm not talking about the regular comments, I'm talking about commenting out tests. What happens when you have these things in your tests? You can imagine the developer, no one will ever delete these things, ever. In 5 years, these comments will exist. And the reason? Nobody knows why they were commented out. Nobody knows if they will be someday commented back in. Nobody knows. What's the point? Must be important. And so it will stay there forever, not doing anything, but just making everyone ask unnecessary questions. So I also tell people when I teach unit testing is that imagine that the person who's going to read your code is a serial killer that knows where you live. You don't want them to start asking unnecessary questions. But in this case, that serial killer is going to take an axe, come to your house and start asking, hey, what's that comment about really? What about naming? Well, naming is one of the things that I think people really miss the most. In this case, we have a test for text with an undefined. And then at the end, notice that there is a message. The last parameter of the equal is what to put out, what to print out if the test fails. And notice the message, text undefined is chainable. Of course, this is a bug fix, but then my question is chainable the bug or is chainable the fix? Which one of them is the important one? Should it be chainable or should it not? Okay? So the way I like to name my test is that I have 3 pieces of information somewhere so that the reader can understand what's going on. And I find that even if you leave out one of those things, the reader is going to have questions. And then they have to read the code of your test. And in this case, it's the unit of work or the entry point to the unit of work. And then we have scenario, which is under which conditions are we testing. In this case, the scenario is undefined. And then the expected behavior. And it should be in the name. So in this case, it would be text with undefined, and then I would either write can be chained or should not be chained. Either one. But I would write it at the name of the test, not at the message of the equals or the asserts. And in fact, I would argue that you shouldn't be writing any messages as the last parameter of the asserts. Because if the test name is good enough, you wouldn't have to. And when you see just the test name, you don't see all those messages when the test failed. You just see some of them, and then you see stack trace. But the test name is the first thing you see when you have failure. And if the test name is good enough, you might not need to see the code of your test before going to the production code and starting to fix it. Here is an example that I call the test of doom. Okay, lights. Okay, this is the test of doom right there. And when I looked at this test at the beginning, what I saw is this. First of all, 78, we talked about this. But then, remember, this is a very, very long test. At some point, you start understanding that this test is a big, big suite of tests. And then, at some point, you start seeing this. You start seeing all this stuff in this long test. And you start saying, okay, you have to start reading it first, and then time is wasted. Then you go, oh, I understand. This is a separate test. And they're doing a try-catch, because if they don't, all the code below will stop working, will never execute. Lights, please. Okay. So we have multiple tests in a single test, and that's both a readability nightmare and a maintainability nightmare. And one way to fix that is by having some kind of, I don't know, separate test for everything you test. I think that's an important thing that we can do. But it also leads to these things. At the beginning, when QUnit was just starting out, people were abusing it, and they were calling QUnit reset in the beginning and in the middle, and after each and everything that has to be reset. For example, the state. But this is really just an anti-pattern. Whenever you see this, the code is really telling you, you really want different tests to be extracted from here. By the way, do you notice there's like an equal inside an equal? That's got to be fun to debug.
And for whatever reason, your boss comes to you and says, you have to write a test. If you write a test after the fact, you're going to be very unlikely to actually change the code base, because, come on, it's already worked. Why touch it, right? So you're going to basically put all of your effort into writing the test. And I'll show you what kind of problems it creates. Now, I highlighted the problematic parts. So first of all, it's a singleton, which means we only get a one chance at instantiating this beast. Then I need to create a cert username and password, but it doesn't ask for a cert username and password. Instead, it asks for a config. So on the right-hand side, I'm going to have to make a config. I'm going to have to make a user. I'm going to have to set username and password on user, and then take the user and put it in the config. And it also wants the certificate, so I'm going to have to make the certificate, put it in the file system, write it out in the file system, close this stream, put the path of the temporary location of the first system in there, and so on and so forth. Right? All the stuff I have to do to kind of please the constructor. Now, this brings a very interesting point, and that is, inbox syncer is probably written in a very untestable manner. And I would then assume that if a piece of code is written in an untestable manner, the rest of the system is written in an untestable manner, right? So the test here makes a huge assumption that I can actually instantiate a user. Who knows? Maybe a user has some crazy constructor that prevents me from instantiating it and further complicating this test. Maybe I cannot get a hold of the config object. Maybe the config object is configured out of some XML file, in which case makes this thing even further and more complicated to instantiate. So what you see on the right-hand side is the best case scenario where the only class that's hard to test is this class over here. Reality is going to be that the problem is going to extend into supporting classes as well. And it's going to be like a little string you have on your sweater. You start pulling on it, and the whole sweater comes unraveled. So let's see, what do we do next? Then we have to create the supporting objects, right? So for more stuff to create, we can create the inbox, we put the messages in the inbox. We have to start a server because we're going to have to be talking to a server because there's a socket that's happening. Then finally, we're going to have to shut down the server inside of a test, which means this test is going to be slow. And all this work, and we really haven't gotten to the meat of it, which is, where is the test, right? Finally, we can basically write something like this, which is, here's the test. The trouble with this test is that it doesn't tell a story. Like, I don't know why this, I don't understand, looking at a test, why all these pieces were set up in the way they were. And why were they assigned and set in a particular way, and things were written in the file system. And like, it makes no sense if you look at it, right? There's no rhyme and reason to it. The trouble is that if you have a test like that and somebody deletes your code and then later on you need to reconstruct your code base from this kinds of test, I would claim that it's next to impossible. Because even though you have these tests, you don't know why they were written. So, could you write an implementation given this test? And I'm going to argue, well, probably not. You just don't know what's going on and why all these things got instantiated. So, let's see if we can do something better and basically flip this thing around and write a test first. Now, people have been abusing tests for a while. So if you write a test like this, the trouble with this test, among other things, is that this test is very intimate with the implementation. If you change anything in the way the bootstrapping sequence works, or in the way the application actually does things, these mocks will break. And so this is actually a liability. It's not an asset. Because every time you refactor your code base, you have all these tests that break, and you have to go and fix them. And the reason they break is because they're too intimate. They know too much about how the things are done, because I had to mock out too many pieces in order to get there. Okay, so let's talk about specs. What's specs? Specs is just tests with a lot of syntactic sugar, and sugar makes everything taste better, so let's talk about specs. And this time, let's write the test first and then write the implementation. So what would a spec look like? It would basically look like this. Well, I have this thing inbox syncer, and what it should do? Well, it should sync messages from the POP server since the last sync. It should close the connection even when the execution exception is thrown. It should sync messages only when the message has not already been synced, and so on, right? These are stories that you can get behind. And I'm gonna basically say that even if I gave you nothing else, just the names of these methods, you would probably write some kind of a class that would actually do what we wanted, right? Something that you wouldn't be able to do from the tests that are written after the fact, because what does it mean, test sync? Nothing, right? Whereas here, there's a story that we're exercising. Now, as I said, one of the biggest things you're gonna do inside of your test is you're gonna instantiate other objects. You're gonna basically wire mini versions of your applications together. So in order to prove to you that it should sync messages from a particular date, I would basically create a whole bunch of dates called long ago now, and I would create a fake POP connector because I don't want to talk to the real server. And I would create the inbox and a filter that doesn't do anything because really I just don't want to test the filter right now. And I would create two messages long ago and a past message, and I would instantiate the syncer, pass in all these things in there because those are all the things that it needs to decide. And call the sync method with a particular time, which is now. What you have done without even actually realizing is you made sure that all the dependencies came from the test and were passed into your application. This isn't some special way of writing code. This is something naturally that comes to us when we have to write a test. Nobody, if I say write a test first and there's no code base, pre-existing code base to deal with, nobody in their right mind is going to write this. Where is this set up with it? Nobody in their right mind is going to write this. Like, why would you write this? Right? Everybody's going to write something along the lines of this code base. It's simpler, it's cleaner, you know what you understand. And why is it that you can do this? You can do this because you're essentially defining the API. Nothing is written yet, right? And you're free to do anything you want. So obviously you're going to think of the most simplest thing you can possibly think of, and you're going to do that. Because why make the world complicated? In essence, what you're doing is you're doing API first, implementation later, which is very different to what most people do. Most people do implementation first, API incidental, right? The API is very much incidental to your development process. So if you write a test, you're not only testing that the code does the right thing, you're also writing essentially a test that the code can be used in the same manner. And lastly, you know, as I said earlier, this is a story I can get behind. I understand why two messages are being created, and I understand what the assertions are about, right? Because it's a specific path that I'm testing. It's not just a random method. Similarly, I can do the same exact thing for it should close the connection even when exception is thrown. You know, I can make a fake exception. I can take the filter dependency and I can turn it into a filter that throws exceptions in order to simulate this thing. I can then create the sync and I can pass in nulls, basically saying, look, you don't need these other objects in this particular test. You're not even going to get there because the exception is going to be thrown before you even get a chance to go there. So whatever the failure is going to be, it's not going to be in those objects. So why make them? And then I can write a test, basically, that says that the exception that was thrown is of the specific type that I expected to be there. So given specs like this, ask yourself, would it be easy for you to write an implementation? I hope the answer is yes.
Oral B. Okay, so the question is, I've got this code sandbox, and actually the tests don't actually run in there, so I'm going to need to clone this. We'll clone, go to my desktop, git clone that thing, and we'll cd into React testing library with use context. And Eric Peter says that he gets really excited when he sees a notification I'm going live. That's very nice. Thanks, Eric. Thanks for smashing that bell. Okay, cool. So we'll just look at it in here instead of the code sandbox. I think that probably will be better off. And I did put a link to this tweet so you can find the Stack Overflow question and all of this other stuff in the description of the video. So cool. Now that we are set here, I'm going to run my alias to run the test, npm test. And that gets all the tests running. We've got 2 tests in here. One of them is passing. One of them is not. So I'm actually going to just hit the F key to run only the failing tests. And now we are off to the races. Our question asker is wondering, hey, why are these tests failing? I don't feel like they should. So the test is this menu item test. And here we're using cleanup from React testing library and all that stuff, which typically you'd have some in a setup test file or something. But that is working correctly. One thing, I looked at this beforehand, one thing that is not correct, Yuri, is putting jest.mock inside of a callback function will not work. Or at least it won't work the way that you think it does. So jest, and I kind of wish that jest would throw an error or something when it sees something like this. But for jest mocks to work, let's think about the code path that things are going through. We're going to import React, so we run all the React code. Then we import React testing library. We run all the React testing library code and all of the imports that React testing library makes, which is into React DOM. So by the time we get here, we have React DOM and everything in that. All of that code has actually run, and all those dependencies and everything have all run, been resolved. And then we import menu item. And if we go to menu item in here, then we're going to import React. That code is already run, so we just get the export. We're going to import this MobX React Lite, so it's going to run all of that code. And then we're going to import use selectable, which is going to import these things. React code is already run, so we just grab the exports. The provider has not yet run, so we'll jump into that. The store hasn't run, so we'll jump into that. We'll the MobX now, and so we're going to pull that in. And ultimately, then we run all of this code. So we're trying to mock out the provider. Well, if we jump into here and then in here, we've already run the provider. So you're trying to mock this module, but it's already been run. So like you can't mock it later. So that's the biggest problem with mocks in general, is like, how do you make sure that your mock is picked up ahead of time? And the way that it works, the way that Jest makes it work, is when it compiles everything, it's going to move every call to Jest mock to the very top of the file to make sure that's happened before. Now, this also doesn't work. The reason I'm getting red underlines is because imports need to be at the top And this is just an ESLint rule to tell you to do that. And the reason, like this is syntactically correct, like it works, but the reason the ESLint rule exists is because while the code may appear this way, the code will actually run this way. Because imports are always hoisted. They're always run first, no matter where they appear in the file. Whoops, that is not what I wanted to do. Where I lost it. There we go. So no matter where these imports appear in the file, they can't be inside of a closure. That is a syntax error. But if they appear down here or down at the very bottom, they're always going to run first. So what happens is just like we're using Babel to compile this down to common.js, and so this changes to React from, or not from, but equals require React, and then it does the same for all those other imports, and then this moves to the top, and that works. So that's how that works. So now that we understand that's how that works, you'll understand that putting a just.mock inside of a callback like this or inside of a test, which is where that's going to be running, that's not going to work the way that you think it does. So that's an important distinction to make, is that just.mock should always be at the root of your module. And yeah, so that's a useful thing to know. Cool. So yeah, so we'll take care of that first. That's not going to affect our test. That was just something that I noticed as I was looking at this, and I thought I'd mention that. Something else I just noticed is my green screen is not getting keyed out properly for some reason. I think I may need to rekey this or something, because that color must be off. Sorry about that. I'll take a look at that later. Maybe some like lights change over time or something. Okay, so yeah, let's see what's going on here. So we test should show span after clicking the category title. So we say render component, that's going to render our menu item with that category, category of size in this case. We expect query by text size is selected to be null, so we don't expect that to be there. Here, you know what? I'm going to actually just run should show span after clicking category title. So we just run the one test. And you know what else? I'm just going to get rid of this app test too, because we don't need that. Just have as few things running as possible. Should show span after that. Okay, sweet. So we expected something to be null, span, or yeah, span size is selected. So we expected that to be null, but it's actually not. Oh, that's on line 30 actually. So let's take a look at how this thing is even implemented, because I don't know what we're looking at. So MobX React Lite, we've got an observer, higher order component thing that takes props, use selectable. Use selectable is a custom hook, I think. Yeah, that's this thing. And that'll pull the store context, and is selected determines whether or not we show it. Okay, so the is selected state except a little halo on retina displays. Oh, interesting. Okay. Let's see. So this is like, I've never used MobX before, but hopefully we can figure out what's going on. So what I'm going to do here is we'll do, when we say get by size, click on that size button. So on click props category, and the category is size. Okay, so that makes sense. So we click on it, and then we have on select, and then use selectable, that on select. Oh, there it is. Okay. So this, we're using use callback, and yeah, store select category. So we've got our store. Yeah. Oh, okay. So make a new store here. Let's make sure that we're mocking the provider properly. Interesting. Okay, well, I'm not going to dive too much further into this particular thing because I'm actually going to recommend that we do not mock the context. Yeah, let me see here. We've got our store context. Yeah, because like we're not doing our mock is doing exactly the same thing as the provider. So it imports React, imports the store, we make a new store, we create context with that store. So the mock actually doesn't do anything for us. It just does the exact same thing. I'm just gonna get rid of that mock, which itself simplifies things considerably. Okay, so in here we do on select. Let's open up this selectable, keep that open. The store context, we use store.selected category. So we're going to need to get the store and set select category, takes the category, and it assigns the category to the given category. So this is kind of a toggle situation. So if the current category is the same as the given category, then we change the current category to null. Otherwise, we set it to the new category, which is kind of almost a toggle sort of situation. And so let's see, we render that, we click on the button, on select, and then we have this nice little console log, which will give us exactly what the state is. So this is the initial when we render the first time, and then this is after we click, and we get is selected as false the first time, which is matches this assertion. And then we click on it, and then we say size is selected to be null again. I think that is a problematic test. I think the expectation is that it's not null. Based on the code here, the assertion was wrong. The assertion should say that it is selected now because I clicked on it. So hopefully that's correct. The original question was, hey, I think we're getting the context persists between tests. And yes, that is true. So to actually answer that question, let's go ahead and get this second one running, and we'll see that that is true. So we'll run all the tests, and that is happening now. If I skip this one, then the second one passes. So that is the original problem that this Yuri guy is struggling with is, hey, my tests are mucking around with each other. And this is when you know you aren't cleaning up after yourself, because, and that's probably why Yuri was trying to do a mock inside of here, is because he said, well, I mean, if we initialize the mock every single time I call render component, then we're going to have we'll have a clean store. And that's probably why Yuri wanted to try and do the mock, was to clean up the store. But that's, as I explained at the beginning, that's not how mocks work. And I kind of wish that Jest would just throw an error and say, hey, this should be at the root of the module, but it doesn't. So how do we do this? What like the core problem is you're not cleaning up after yourself, and that is a pretty common issue. I've actually got a blog post that's sort of about this. Test isolation in React. I gotta delete my old blog post stuff. So test isolation with React, where I kind of talk about the importance of making sure your tests are isolated because it presents these problems. I don't know whether you read this post, but he recognized this as a potential problem. And so here's what we're going to do. We're going to take a look at our store here. And what I would do is I'd actually have a method on the store that is like reset or something. Typically I find that to be useful in applications anyway. But I don't often, if it's not, I don't often like adding code just for testing purposes. I'm fine with restructuring code to make it easier to test, because often it makes it easier to maintain as well. But yeah, we don't have to change the code to make the tests work. So what we're going to do instead is I'm going to import our store yeah, we'll just import the store as is. Oh, actually, no, we need a store instance. So let's think about this. Okay, so well here, I'll show you the really easy way to fix this problem. We're gonna say before each jest.reset modules, and that'll fix it. Should have fixed it, but it didn't. That's weird. Reset modules did not fix it. That's odd. Okay, that doesn't fix it. I kind of expected that to work. So what we will do instead. This one is a little bit tricky. So the fundamental problem is we set up some state and we're not cleaning up that state. We're not resetting this. That apparently that state is global. So normally, the menu item. Hold on a second. How's this even working? Because I know how it's working. Oh, okay. I have the solution. And this is, somebody wants to add a comment to the video. This is at like around 15, almost 16 minutes. This is the solution to the problem. Fundamental problem is that our provider provides a default store if no store is provided. I think that for situations like this in particular, that's not a good idea to provide a default store or a default context value. Because normally, like if somebody's rendering a component outside of the provider, then you're going to run into problems like this. And so you want to make sure that all components are being rendered within the provider. Okay, so how do we solve this problem? We're going to import the provider. So we'll import, and actually we're export default the store context. So this is actually not the provider. This file should be changed. I'm going to rework a couple of things, but we'll work with what we have right now, and then I'll show you the reworking. So we're going to import store context from provider, and then we're going to render the store context around our menu item category. So this is how you, like, the title of the video is how do you test a thing that's using use context. This is how you do it. You make sure that the provider, so the store context object has a provider component you can render, and then you specify a value. And so then we're going to need a value. It's going to need to be our store. So we're going to have a store that's from store. And our value is going to be a new store. And there we go. Now it's busted. Cannot read property provider of undefined because this is a named export. So this needs to be a named import. Sweet. And that fixes the problem. So why does that fix the problem? It fixes the problem because each call to this render component is rendering the menu item within a store context provider that has its own store. So they're totally separate from each other. They're not sharing any state or anything like that. That is great design. So how would I change some of this stuff? Well, first of all, I would actually make a function here called useStore that's going to return, or we're actually going to say our store equals react.useContext store context. And I'm going to say if there's not a store, then I'm going to throw a new error that says must use cannot use store outside of a store provider. And we'll export that use store. And then we're also going to get our provider out of store context, and we'll export that as well. Whoops. So we have our provider and we have our store, and then I'm going to not export the store context. People will, if they want to use that, or if they want to use the store, they have to use this use store. And of course, this needs to return the store. Okay, so that means that instead of use selectable using the store context like this, we're going to import use store, and we'll do all of this instead. And we no longer get that. We don't need that. And then in our app, I don't know if this is actually being used in the app. Yeah, so here we're using this menu item and stuff. So that before, this kind of relied on some global store that existed by default, but now we're going to rely on the fact that you have to render the provider first. So we're going to import provider from our provider, and then we'll render provider. And then this will also need to import the store from store. This will be value is new store. And then of course, prettier is not set up in this project, so it's not auto formatting, which is a shame. But yeah, so I got to clean up a couple other things for our test, but that's what it would look like in here. Let me make sure we're doing a default export of that store. Yep. Okay, cool. So with that, now we can go into our test, and we'll import the provider and well, we don't need use store. We just need the provider. So we do basically what our app does. That's the fundamental concept, is that you do what the app does. And we're just going to export that provider. Now, if you didn't want to like have to in our app, if you didn't want to have to do this store thing, then here's another thing that I think is totally legit, is instead you make a function called provider. You take props, you return store context dot provider, and spread the props. And then we're going to say the value is a new store. And then we'll import store from store. And then we'll export that provider. Okay, and the reason that this is a good idea is because it allows me as a user of the provider to override that store value really easily. So I can come in here and I'm using that provider, I'm overriding the store value. If I don't need to, if I'm fine using the store that it gives me, then I just remove that one. But every single time I render that particular provider, I'm going to get a new store. So if this provider is re-rendered, I'm going to make a new store. So I'd probably not want to do this. And what I'd do is I'd say const store, or store equals react.use memo and new store. And then I'm not going to have any dependencies. So it's going to be the same store every time for the lifetime of this component. That's probably the way I would do this. And if the store needed like some configuration or something, then you'd put that in your use memo dependencies list. But yeah, in any case, that's going to fix our tests, because every time I call this render component, it's going to render my menu item within the provider. So this all comes back down to testinglibrary.com. If you go to docs, and then we're going to go to React testing library setup. So the React testing library setup recommends that first off, you set up files after env to do the cleanup after each for you, which is kind of nice. And then instead of using React testing library, you actually use your own utils. So you create a custom render that's similar to this render component function. And so the way that this is written is you import all of the stuff, so your providers and whatever else. And then you have all the providers. You have a function that has all of those providers. And then you create a custom render method similar to what this is doing. And then you re-export everything from React testing library, and then you override the render export with your custom one. And that allows you to render all of your components however you want. It doesn't matter. They'll always have the provider that they need. This is really key, that your components are rendered with an actual real provider, because that's how it's going to work in your actual app. So you want to know what your actual app is going to do. So a couple changes here that I'm going to make is render actually accepts a wrapper option, and our wrapper is this provider. And so then we can get rid of wrapping this thing with the provider because React's testing library will do that for us. And the benefit of that is if you had a re-render here, then you could call re-render with menu item and a category of foo and change the category, re-render it, but it would still be rendered within this provider. So you don't have to wrap this in a provider again and so on and so forth. You just re-render that and it'll be wrapped in your provider. That's the benefit of doing the wrapper. But in any case, having a render component, and what I'm going to do here instead, I'm going to make a function that is our custom render. And actually, well, let's do this as RTL render. And we'll just call this one render. This will take our UI and options, and we'll return return RTL render with the UI and options. Okay, so far this render doesn't do anything different from RTL render. And here's where things are going to change. I'm going to take those options and spread those, and I'm going to add my own option, which is the store. And we're going to spread those options, options. And I'm going to say wrapper is we'll take a function, our wrapper. Okay, so now we're going to return, here, we'll do things one at a time. So we've just got this options. Now we're going to return provider, and we'll take these props and we'll just spread those props. The only prop you're going to get for your wrapper is children, but we'll just do that, do it that way. Okay, so now we'll get rid of this render component, and instead we'll say render menu item where the category is size. And we can just use it like that, like we kind of want to. We just want to render the component we care about. And we don't care about the fact that render actually wraps everything in the provider. It just kind of happens. We'll do the same thing for this one. And let's get rid of this thing. And cool, tests are still passing. So then what if I wanted to configure the store in some way, or maybe provide my own instance of the store? That's where this options comes in really handy. Is I'm going to just take those options, we'll take a store off of that, and we'll make a default store. So we'll say, and actually this needs to be a default object as well. But we'll import store from store, and we'll say new store. And then we'll say our value is that store. Okay, cool. So the benefit of that is that now we can configure our own store. So I can say render with a store that is my new store, and I can configure it however I want. I want it like whatever I want to do there. I have all of the power. The tests are still passing here, but I get to choose how things are operating because I specify my own options. So then, like, you do this for all of your providers. You take this render method, you put it into a special file, and then you can actually configure your test utils file so that it almost looks like a node module. Or you could just publish it to npm, but you don't have to do that. You can put it in some special directory, like a utils folder, or I put it in a test folder. But in any case, you make it so that's accessible anywhere, and then yeah, you just magic happens, and it's awesome. And instead of importing from React testing library, you import from test utils. And yes, Nerd Donnie just noticed I missed a P. So yeah, hopefully that's helpful. This is like a really fundamental, important concept in any application of any significant size. I'm going to create a custom render method, and I'm going to follow these instructions for setup. You don't have to do this, like it's fine, but it works better if you do, particularly this custom render thing. Okay, cool. So that is the dev tip of the day.